Hello, my name's Angus Robinson from the Anritsu company. I'm a product manager for the handheld product line, and today I want to talk a little bit about the calibration options that are available to you when you're using the SiteMaster in the field to measure the return loss or VSWR of antenna cable feeds and antennas themselves. So when we're installing and maintaining these sort of RF cables and antennas that are typically used on modern communication systems, either LMR or cellular. In order to measure the return loss on those antenna feeds, the first thing we always need to do is calibrate the instrument. We need to correct for source match errors, for directivity errors, for system errors at the test port. And with the SiteMaster we have three options as to how we can do that. The first option is to use the factory calibration data, which we call ReadyCal. The second option is to use the traditional and familiar open short load mechanical calibration piece. And the third option is to use an InstaCal module, which effectively integrates an open, a short and a load into a single module with a switch in front of them that is controlled by a USB cable from the instrument itself. So let's have a look at the first of those options, which is the ReadyCal. When we manufacture the instrument, in production we generate calibration data that is good for making a return loss measurement or an insertion loss measurement under certain specifically defined conditions. And essentially those are if we're at ambient room temperature, around about 20 degrees centigrade, and if we're making a measurement at the test port itself, because that calibration data was calculated using calibration pieces on the test port. If we're using the test port cable to give us a 1 meter or 3 foot extension between the test port and the system that we're testing, we shouldn't be using the ReadyCal data because that isn't correcting for the errors introduced by the cable itself. So let's just have a look at, we're sweeping here from roughly DC to 6 gigahertz, and I've got a precision load. So I'm going to put the precision load onto the test port. I've got the ReadyCal data being applied. It's applied by default when we turn the instrument on. And having connected up the load and just using a torque wrench to tighten that up nicely, we can see here on the screen that we're getting around about 40, better than 40 dB's return loss measurement on this. If I go into the marker menu and do a marker peak search, the highest reflection there is at about 42.7 dB's. So the ReadyCal at room temperature at the test port does give us a very good directivity, a very good ability to measure return loss. I'm now going to take off the load from the test port, and we're going to repeat the measurement of this load, but this time after having done a calibration with the mechanical open short load. So I need to go into the calibrate menu, select Cal method and select standard open short load, and when I press the start Cal button here, it pops up a diagram showing me that I need to connect, first of all, the open circuit to the test port. So, connecting up the open circuit here, and again using the torque wrench to get that final good connection. I then press measure, and we calculate we measure the reflection from the open circuit. We can see the trace sweeping across the screen there. Now it's telling me to connect the short circuit to the test port. So again, using the torque wrench, I just loosen that off. And connect the short circuit to the test port. Torque that up and press measure again. and when it's completed the sweep for the short circuit, it will prompt me to connect the load to the test port. So you can see with the mechanical device, I need to make, I have three processes that I need to go through: the open, short and load. And it does take a little bit of time to physically make those three connections. So here we are connecting up the load. Here's the torque wrench again. Press measure. That's completed our calibration process. I'm going to apply that calibration data. Now, because the same load is still connected to the test port, that's the load that was used for the correction coefficient. So that is going to give us like a perfect return loss. So let's connect the load that we looked at before and compare the return loss we measure on our precision load. Torque that up. And on torquing that up, you can see this is exceptionally flat. It's better than 45 dB return loss all the way up to 6 gigahertz. We can see that the marker is showing us that the trace is below 45 dB return loss right up to 6 gigahertz. The final calibration that we're going to do is with the InstaCal. So now I go back into the calibration menu, go to Method, and I select InstaCal Open Short Load, Start Calibration, and it shows me to connect the InstaCal to the test port. So let me just do that up. Now in this instance, I will only have to make the connection once because this will switch between the open, short and load in the module under control of the USB cable. So let me just torque that up, press measure, it says measuring open, now measuring short, now measuring load, and now the calibration is complete. So I'll apply that calibration data, and now I once again connect the precision load to the test port to compare the return loss that we measure on that precision load. But you can see the benefit of the InstaCal there is that I only had to make one connection to the test port to do the open short load sweep. Reconnect the precision load. So with the InstaCal, you can see that the dynamic range is a little bit less than for the mechanical cal device, but still better than 45 dB's directivity up to 5 gigahertz, just decreasing a little bit as we get up to 6 gigahertz. For most LMR systems and cellular systems, we're working below 4 gigahertz, 4.2 gigahertz, so actually the InstaCal works really well. So to summarize, we have three calibration options. We can use the factory cal, the ready cal, straight out of the box as soon as we turn the instrument on. And that's fine as long as we're working at close to room temperature and we're making our measurements at the test port. Otherwise, we need to use either the mechanical cal device or the InstaCal device. The InstaCal device is faster and more convenient. The very best performance up to 6 gigahertz is achieved with the mechanical calibration. but in reality, all three of those calibration processes give you very good results in most normal operating conditions. Thank you very much for watching.